picture this for a moment. You're standing on the shore of the Mediterranean Sea at sunset, watching golden waves crash against ancient limestone cliffs that have witnessed the rise and fall of countless empires. The water stretches endlessly toward the horizon, its surface reflecting the dying light like a mirror made of liquid gold. Beneath your feet, fragments of pottery worn smooth by centuries of tides hint at civilizations that once called this coastline home. The air carries the salt smell of deep ocean mixed with something else, something that feels almost like memory itself. You're looking at one of humanity's oldest highways, a body of water that has carried Phoenician traders, Roman legions, Byzantine merchants, and crusader fleets across its blue expanse for thousands of years. Every island, every inlet, every submerged reef has a story to tell. But here's what's truly remarkable despite all our archaeological efforts. Despite centuries of exploration and excavation, we've barely scratched the surface of what lies hidden beneath these ancient waters. The Mediterranean Sea covers nearly 1 million square miles and reaches depths of over 17,000 feet. Marine archaeologists estimate that more than 3 million shipwrecks rest on its seafloor, vessels spanning over 3,000 years of human history. But shipwrecks are just the beginning. Beneath the waves lie entire cities, complete harbors, temples, palaces, and residential districts that were once bustling centers of human activity. When the last ice age ended roughly 12,000 years ago, sea levels rose by more than 400 feet, permanently flooding vast areas of coastal land where early civilizations had established their settlements. These weren't primitive villages. Archaeological evidence suggests that some of these submerged sites were sophisticated urban centers with complex architecture, advanced engineering, and thriving economies. Yet most of these underwater ruins remain completely unexplored. We know they're there, scattered across the seafloor like a vast underwater museum. But the technology and resources required to properly investigate them are still beyond our reach. And that's just what we can see with sonar and submersibles. How much more lies buried beneath centuries of sediment, invisible to our current detection methods? This brings us to a disturbing realization. If entire cities from just 12,000 years ago can vanish so completely that we're only now beginning to rediscover them, what about civilizations that might have existed much earlier? What about advanced societies that might have flourished 50,000 years ago, or 100,000, or even longer? There are currently over 8 billion people living on our planet. Each day, roughly 385,000 babies are born while 158,000 people pass away. Every single human being leaves traces of their existence: carbon footprints, digital records, chemical signatures in the soil, modifications to the landscape. Our cities glow with artificial light visible from space. Our agricultural activities have altered the nitrogen cycle of the entire planet. Our industrial processes have changed the isotopic composition of the atmosphere itself. But here's the unsettling truth that keeps archaeologists and anthropologists awake at night. These traces won't last forever. Our concrete cities will crumble within a few centuries. Our steel structures will rust away. Our plastic waste, which we consider virtually indestructible, will eventually break down into molecular components. Even our nuclear waste, which we regard as essentially eternal, will eventually become undetectable background radiation scattered throughout the environment. The half-life of plutonium-239, one of the longest-lasting byproducts of nuclear weapons and power generation, is about 24,000 years. That sounds like forever from a human perspective, but it's barely a moment in geological time. After 10 half-lives, roughly 240,000 years, the radioactive signature of our nuclear age will have decayed to less than 1,000th of its current intensity. After 1,000,000 years, it will be essentially undetectable. So here's the question that should give us all pause. If our advanced technological civilization, with all its massive infrastructure and global environmental impact, can vanish so completely within a relatively short period of geological time, how many others have already done exactly that? How many previous chapters in the story of intelligence on Earth have been written and then erased so thoroughly that we have no idea they ever existed? And what can the legend of Atlantis, that most enduring of all lost civilization myths, teach us about the impermanence of human achievement and the cyclical nature of progress and collapse? Let's dive into what I call the Atlantis paradox, the idea that advanced civilizations don't just decline or fall. They vanish so completely from the historical record that their very existence becomes legend, then myth, and eventually nothing at all. It's a concept that challenges everything we think we know about human history and forces us to confront some uncomfortable truths about our own civilization's ultimate fate. When the Greek philosopher Plato first wrote about Atlantis in his dialogues, Timaeus and Critias, around 360 BCE, he wasn't trying to create an entertaining piece of fiction. He was doing something far more serious, preserving what he believed to be an authentic historical account that had been passed down through generations of oral tradition, from Egyptian priests to the Athenian statesman Solon, and finally to Plato himself. According to Plato's detailed description, Atlantis was a maritime civilization that existed approximately 9,000 years before his own time, roughly 11,000 years ago from our current perspective. This would place Atlantean civilization right at the end of the last ice age, during a period of dramatic climatic upheaval, when sea levels were rising rapidly and entire landscapes were being transformed. But Atlantis wasn't just any civilization. Plato described it as a naval power so advanced and sophisticated that it could challenge ancient Athens itself, which he considered the pinnacle of human achievement. The Atlanteans possessed engineering capabilities that allowed them to construct massive harbor works, create artificial islands, and build concentric rings of canals that brought ocean water deep inland to service their capital city. Their agricultural system was so efficient that they could support a population far larger than any known ancient civilization. Their military was organized and equipped with bronze weapons, horse-drawn chariots, and a navy of 1,200 ships. They had established trade networks that extended across the known world, bringing them wealth in gold, silver, and precious stones. Their architecture incorporated advanced techniques for working with different metals, and they had developed sophisticated artistic traditions that combined functionality with beauty. Most remarkably, Plato described Atlantean society as having reached a level of political and social organization that represented, in his view, an ideal balance between individual freedom and collective responsibility. For centuries, their civilization flourished in peace and prosperity, achieving technological and cultural heights that wouldn't be matched again for millennia. Then, according to the account, something went wrong. The Atlanteans became corrupted by their own success, growing arrogant and aggressive in their dealings with other nations. They launched military campaigns aimed at conquering the entire Mediterranean world, including ancient Athens. And it was at this moment of peak hubris and expansion that catastrophe struck. In a single day and night, Plato wrote, Atlantis was destroyed by earthquakes and floods of extraordinary violence. The entire civilization, its cities, its people, its accumulated knowledge and achievements was swallowed by the sea and erased from existence. Where once had stood the most advanced civilization in the known world, there remained only empty ocean. Now, most classical scholars today consider Atlantis to be Plato's philosophical allegory, a cautionary tale about the dangers of hubris, moral decay, and the abuse of power. They point out that Plato often used fictional narratives to illustrate abstract philosophical points, and they argue that the story of Atlantis serves as a warning about what happens to civilizations that lose sight of justice and virtue. But what if we're missing something crucial here? What if Plato wasn't creating an allegory, but rather preserving the fading memory of something that actually happened? What if he was trying to record, in the only way available to him, an account of a real civilization whose destruction had become so distant in time that it survived only in garbled oral traditions and fragmentary memories passed down through generations of storytellers? Think about how quickly and thoroughly we forget even recent history. The average human lifespan is roughly 78 years. That means every single century, most of the people who personally witnessed major historical events are gone forever. Their memories die with them unless they've been carefully recorded and preserved in some permanent form. And even when events are recorded, the records themselves are fragile and perishable. Languages change and become incomprehensible. Writing systems are forgotten. Libraries burn down. Political upheavals destroy archives. Religious conflicts eradicate the cultural heritage of defeated peoples. Natural disasters bury entire cities beneath sand, mud, or volcanic ash. Consider what we call the Bronze Age collapse, a period around 1200 BCE, when numerous advanced civilizations around the Mediterranean and Near East suddenly disappeared within the span of just a few decades. The Mycenaean Greeks, the Hittite Empire, the Kassite dynasty in Babylon, the New Kingdom of Egypt, all these sophisticated societies with their complex political structures, extensive trade networks, and impressive architectural achievements either collapsed entirely or underwent such dramatic transformations that they became unrecognizable. We still don't fully understand what caused this widespread civilizational collapse. The historical record from this period is fragmentary and confusing. Some texts mention invasions by mysterious sea peoples whose origins remain unknown. Others describe famines, plagues, internal rebellions, and natural disasters. But the exact sequence of events, the connections between different regional collapses, and the ultimate causes of this widespread catastrophe remain hotly debated among historians and archaeologists. And this happened only about 3,000 years ago, practically yesterday, in terms of human history. If civilizations from the relatively recent Bronze Age can disappear so thoroughly that we're still trying to piece together what happened to them, what about much older civilizations? What about societies that might have existed not 3,000 years ago, but 30,000 or 300,000? Let me give you an even more dramatic example of how completely civilizations can vanish from historical memory. The Library of Alexandria was, for nearly 700 years, the greatest repository of human knowledge in the ancient world. Founded in the 3rd century BCE by the Ptolemaic rulers of Egypt, it was designed to be a universal library containing all human knowledge. Scholars estimate that at its peak, the library contained between 400,000 and 700,000 individual scrolls covering mathematics, astronomy, physics, natural sciences, medicine, literature, history, philosophy, and geography from cultures across the known world. The library employed hundreds of scholars and scribes who worked full-time copying manuscripts, translating texts between languages, and creating new works of scholarship. For centuries, the Library of Alexandria was the intellectual heart of the Mediterranean world. The greatest minds of antiquity studied there, mathematicians like Euclid and Eratosthenes, astronomers like Hipparchus and Ptolemy, physicians like Herophilus and Erasistratus. The knowledge contained within its walls represented the accumulated wisdom of dozens of civilizations spanning over a millennium of human intellectual development. Then, gradually, over the course of several centuries, it all disappeared. There wasn't a single catastrophic destruction. Instead, the library declined through a combination of political upheaval, religious conflict, reduced funding, changing intellectual priorities, and simple neglect. Different parts of the collection were dispersed, destroyed, or simply allowed to decay. By the time the last scholars abandoned the site sometime during the early medieval period, virtually nothing remained. The loss was incalculable. Entire fields of ancient knowledge simply vanished. We know from fragmentary references in surviving texts that ancient scholars had developed sophisticated theories about astronomy, mathematics, geography, and natural science that wouldn't be rediscovered until the Renaissance, if they were ever rediscovered at all. How many technological innovations, philosophical insights, historical chronicles, and scientific discoveries were lost forever when the Library of Alexandria crumbled into dust? But here's the truly disturbing part. We don't even know exactly what was lost, because the catalogues and inventories were destroyed along with everything else. We're trying to understand the magnitude of the loss by examining the shadows it cast, references in surviving texts to works that no longer exist, gaps in the historical record where we know important documents once existed, mathematical and scientific problems that ancient scholars apparently solved, but whose solutions are lost to us. How many civilizations were documented in those lost scrolls? How many accounts of technological achievements, cultural practices, and historical events simply vanished along with the papyrus they were written on? How many warnings about natural disasters, descriptions of previous climatic changes, or records of earlier civilizational collapses were filed away in the library's archives, waiting to provide crucial guidance to future generations who would never get the chance to read them? This is what I call the cruel mathematics of memory. Information decays according to relentless physical laws. Knowledge disappears unless it's constantly maintained and transmitted. Languages evolve and become incomprehensible. Technologies are forgotten when the people who understand them die without adequate apprentices. And civilizations, no matter how advanced, sophisticated, or seemingly permanent, can be forgotten completely within just a few generations if the right combination of disasters, conflicts, and cultural disruptions occurs at the critical moment. We like to think that our modern civilization is different, that our advanced communication technologies and distributed information storage systems make us immune to the kind of knowledge loss that befell our ancestors. But are we really so different? How much of our most important knowledge exists only in digital formats that could become unreadable within decades if the supporting technology disappears? How many crucial skills and techniques are known only to small groups of specialists who haven't adequately documented their methods for future generations? And what about the bigger picture? If our industrial civilization collapsed tomorrow due to climate change, resource depletion, economic crisis, or some other systemic failure, how long would it take for future archaeologists to lose track of our existence entirely? How quickly would our cities crumble, our monuments erode, our technological artifacts corrode into unrecognizable fragments? The answer might be more disturbing than we'd like to admit. Here's something that might surprise you about archaeology. It's actually terrible at finding things. I know that sounds contradictory after all. Archaeologists are the people who dig up ancient civilizations for a living, who fill museums with pottery shards and arrowheads and golden funeral masks that bring the past to life for millions of visitors every year. But the dirty secret of archaeology, the thing they don't teach you in introductory textbooks, is that for every artifact we find and carefully catalogue, millions more are gone forever. Let me give you some perspective on the scale of what we're missing. Modern humans, Homo sapiens, have existed for roughly 300,000 years. During that time, we've been burying our dead for at least half that period, often with grave goods that reflect their social status, occupation, and cultural beliefs. Pottery, tools, jewelry, weapons, religious objects, the archaeological record should be absolutely packed with material evidence of human activity spanning millennia. So how much of that record have we actually recovered? Archaeologists estimate that humans have lived in permanent settlements for about 12,000 years, since the beginning of the Neolithic Revolution, when we first developed agriculture. During that time, roughly 100 billion people have lived and died on Earth. If even 1% of them were buried with identifiable grave goods, which is almost certainly a conservative estimate, that would represent 1 billion potential archaeological sites waiting to be discovered. 1 billion sites. Think about that number for a moment. So far, in over 2 centuries of systematic archaeological excavation, we've fully investigated maybe a few 100,000 sites worldwide. That means we've examined roughly 0.01% of the potential archaeological record. We're not just missing pieces of the puzzle, we're missing entire puzzles, whole categories of human experience and cultural development that remain completely unknown to us. And that's just for the period since the development of agriculture, when humans began creating permanent settlements with durable architecture and concentrated populations that would be likely to leave archaeological traces. What about the much longer period of human existence before the Neolithic Revolution? What about the nearly 300,000 years when our ancestors were living as hunter-gatherers, creating tools and art and complex social structures that left minimal traces in the archaeological record? The famous cave paintings at Lascaux in France, created about 17,000 years ago, demonstrate that Paleolithic humans possessed sophisticated artistic abilities and complex symbolic thinking. But cave paintings can only survive under very specific environmental conditions, dry caves with stable temperatures and minimal human disturbance. How many other examples of Paleolithic art existed in less favorable locations and have been completely destroyed by weathering, erosion, or human activity? Similarly, we know from sites like Göbekli Tepe in Turkey that hunter-gatherer societies were capable of creating monumental architecture requiring sophisticated organizational abilities and engineering knowledge. Göbekli Tepe, which dates to about 11,000 years ago, consists of massive stone pillars arranged in circular formations, decorated with intricate carvings of animals and abstract symbols. The site required coordinated labor by hundreds of people over many years, suggesting levels of social organization that we previously thought impossible for pre-agricultural societies. But Göbekli Tepe was only discovered in the 1990s, and it was only recognized as archaeologically significant because a Kurdish shepherd noticed some unusual stones protruding from a hillside. How many other monumental sites from the Paleolithic period remain buried and unrecognized? How many were destroyed by later construction, agricultural activities, or natural processes before anyone realized their significance? The situation becomes even more challenging when we start talking about truly ancient civilizations, ones that might have existed not thousands of years ago, but tens or hundreds of thousands of years ago. The Earth is constantly recycling itself through geological processes that operate on timescales far longer than human history. Plate tectonics continuously creates new land while destroying old landscapes. Erosion wears down mountains and fills in valleys. Volcanic activity buries vast areas under layers of ash and lava. Sea levels rise and fall with climate changes, alternately exposing and submerging coastal areas. Consider the Sahara Desert, which today is one of the most barren and inhospitable regions on Earth. But core samples taken from lakes and ocean sediments reveal that as recently as 12,000 years ago, the Sahara was a lush, green landscape filled with rivers, lakes, and forests. It was home to diverse wildlife, including elephants, giraffes, and hippopotami. Most importantly, it was inhabited by human populations who created sophisticated rock art, developed pottery traditions, and may have established permanent settlements near the major water sources. Then, due to cyclical changes in Earth's orbital patterns, the climate shifted dramatically. The monsoon rains that had sustained the Green Sahara moved southward, and the region gradually transformed into the desert we know today. Entire civilizations could have thrived in the Green Sahara for thousands of years, developing technologies and cultural achievements that we can barely imagine. Today, any evidence of those hypothetical civilizations would be buried under thousands of years of sand dunes, completely invisible to conventional archaeological techniques. Or consider the continental shelves, the shallow underwater areas that surround most continents. During the last ice age, which ended about 12,000 years ago, so much water was locked up in glacial ice that global sea levels were roughly 400 feet lower than they are today. Vast areas of land that are now underwater were once fertile coastal plains where human settlements flourished for millennia. These weren't marginal environments. Coastal areas are typically among the most productive and attractive locations for human habitation. They offer access to both marine and terrestrial resources, provide natural highways for trade and communication, and often have favorable climates moderated by proximity to large bodies of water. If you wanted to predict where advanced prehistoric civilizations would be most likely to develop, coastal areas would be at the top of your list. But when the ice caps melted at the end of the last glacial period, all those coastal settlements were gradually swallowed by rising seas. The process wasn't necessarily catastrophic. Sea levels probably rose slowly enough that most populations could retreat to higher ground, but the physical remains of their settlements would have been permanently submerged and gradually buried under marine sediments. Marine archaeologists have already discovered submerged cities and settlements in the Mediterranean, the Caribbean, the North Sea, and off the coasts of India and Japan. These aren't mythical places like Atlantis. They're real archaeological sites that can be explored with submersibles and underwater excavation equipment. But most of these sites are fragmentary and heavily degraded by centuries or millennia underwater. The organic materials that would tell us the most about their inhabitants' daily lives, wood, textiles, paper, leather, anything made from plant or animal materials, are long gone, destroyed by saltwater, marine organisms, and chemical processes. What survives are primarily the most durable artifacts: stone foundations, ceramic vessels, metal objects that haven't completely corroded away. It's like trying to understand our own civilization by examining only concrete foundations, broken dishes, and scattered pieces of rusted metal. You might be able to infer that an advanced society once existed, but you'd miss most of what made that society unique and sophisticated. And these are just the submerged sites we've managed to locate and investigate. Marine archaeologists estimate that we've explored less than 5% of the world's continental shelves, and most of that exploration has been concentrated in relatively shallow areas close to modern coastlines. Deeper sites, or those located far from current population centers, remain almost completely unknown. This is what I mean by the archaeology of absence. We're not just looking for what's there, we're trying to understand what's missing, and why it's missing, and how much of the human story has been permanently erased by natural processes that operate on timescales far longer than recorded history. But the most unsettling realization is this: if we're missing so much of the archaeological record from the relatively recent past, how can we possibly hope to detect evidence of civilizations that might have existed much earlier? How would we recognize the traces of an advanced society that flourished and disappeared not 12,000 years ago, but 100,000 years ago, or 500,000 years ago, or even longer? The answer, I'm afraid, is that we probably wouldn't recognize them at all, unless they left behind traces of a completely different kind than what we normally think of as archaeological evidence. Now, here's where things get really interesting, and more than a little unsettling. We tend to think that advanced civilizations would necessarily leave behind obvious traces, massive stone monuments, metal tools, complex machinery, evidence of large-scale construction projects. After all, that's how we identify and study ancient Egypt, Rome, the Inca Empire, and other historical civilizations. We look for pyramids, roads, aqueducts, fortifications, temples, durable physical structures that can survive for thousands of years and tell us about the engineering capabilities and social organization of their builders. But what if we're thinking about this all wrong? What if our assumptions about what constitutes advanced technology are fundamentally biased by our own particular moment in technological development? What if the most advanced civilizations are actually the ones that leave the smallest physical footprints? Consider our own technological trajectory over just the past few centuries. 200 years ago, the most advanced societies on Earth were characterized by massive, highly visible industrial infrastructure, enormous factories with towering smokestacks, vast railroad networks stretching across entire continents, telegraph lines supported by millions of wooden poles, coal mines that scarred the landscape for miles around, steel mills that lit up the night sky with their furnaces. These were civilizations built on iron, steam, and combustion, and they left their mark everywhere in the form of pollution, mining scars, deforestation, and monumental engineering projects. If alien archaeologists were to visit Earth 1,000,000 years from now and examine geological layers from the 19th century, they would find abundant evidence of this industrial civilization: coal ash and metal particles in the sediments, distinctive isotopic signatures from fossil fuel combustion, traces of industrial chemicals in ice cores and lake bed samples. The physical infrastructure of industrialization, railroad grades, canal systems, mine shafts would remain visible for hundreds of thousands of years. But look at us today. Our most sophisticated technologies are increasingly miniaturized, efficient, and immaterial. The smartphone you carry in your pocket contains more computing power than room-sized computers of the 1960s. Yet it's made from a tiny amount of carefully refined materials that could completely decompose within decades if the right chemical processes were applied to them. Our most valuable innovations exist primarily as information software, algorithms, data patterns, genetic sequences, mathematical models. These exist as arrangements of electrons in computer memories, or as magnetic patterns on storage devices, or as molecular structures in DNA databases. From a physical perspective, the difference between the most advanced computer program and random electromagnetic noise is essentially invisible. It's all just patterns of energy that happen to be organized in meaningful ways. Our communication systems are increasingly wireless, leaving no permanent physical traces. Our entertainment, education, and social interaction happen in virtual environments that exist only as data streams flowing through networks of fiber optic cables. Our most important work, scientific research, financial transactions, creative expression, political organization happens in cyberspace rather than physical space. Even our manufacturing is becoming more sophisticated and less environmentally disruptive. We're developing nanotechnology that can build complex devices atom by atom. We're creating biological systems that can grow materials with properties superior to anything we can make with traditional industrial processes. We're learning to work with natural systems rather than against them, designing technologies that integrate seamlessly with ecological cycles. This trend is accelerating rapidly. As virtual and augmented reality technologies improve, as artificial intelligence becomes more capable, as we develop better brain, computer interfaces and biotechnology integration, the distinction between real and virtual experience becomes increasingly meaningless. We're already beginning to live primarily in simulated realities of our own creation, and this process shows no signs of slowing down. Now imagine this technological evolution continuing for not decades or centuries, but thousands or millions of years. And sufficiently advanced civilization might eventually develop technologies that are completely sustainable, operating in perfect harmony with natural ecosystems. They might create devices that are indistinguishable from biological organisms, or that exist primarily as self-organizing information patterns rather than physical objects. Such a civilization might build their cities from living materials that grow, adapt, and eventually biodegrade completely when no longer needed. They might power their society using energy sources that leave no chemical signatures, perhaps direct matter to energy conversion, or quantum field manipulation, or techniques for extracting energy from the vacuum itself. They might store their knowledge in formats that appear completely natural, encoding information in DNA sequences, crystal lattice structures, or even quantum field patterns. Most radically, they might eventually transcend physical existence entirely, uploading their consciousness to quantum computers or merging their minds with artificial intelligence systems that operate according to principles we can't even imagine yet. They could create entire universes of pure information where the limitations of physical reality, scarcity, distance, entropy, death simply don't apply. From our perspective, attempting to study such a civilization through conventional archaeology would be completely hopeless. They wouldn't leave behind pyramids or pottery shards. There would be no metal artifacts to excavate, no stone foundations to map, no trash heaps to analyze. They might exist for millions of years, achieving incredible heights of knowledge, creativity, and spiritual development, and then simply vanish without leaving any traces that we would recognize as evidence of intelligence. This creates what I call the technology trap. The more advanced a civilization becomes, the less physical evidence it might leave behind for future archaeologists to discover. Our current assumptions about what constitutes archaeological evidence are based on our own relatively primitive stage of technological development. We're still in the heavy industry phase of civilization, where advanced technology requires massive physical infrastructure and generates obvious environmental signatures. But intelligence might naturally evolve toward greater elegance, efficiency, and integration with natural systems. The most advanced civilizations might be precisely the ones that would be most difficult or impossible to detect using conventional archaeological methods. This has profound implications for how we think about the possibility of ancient, advanced civilizations on Earth. We've been looking for evidence of ancient pyramids, but what if advanced ancient civilizations built structures that were indistinguishable from natural rock formations? We've been looking for metal artifacts, but what if they developed materials that were completely biodegradable? We've been looking for signs of environmental impact, but what if their technology was so sophisticated that it operated in perfect ecological balance? Even more unsettling, what if some of the phenomena we currently interpret as natural are actually technological artifacts from previous civilizations? What if certain geological formations, biological systems, or even physical constants have been subtly modified by intelligence operating on timescales and at levels of sophistication that we can't currently comprehend? Consider the possibility that consciousness itself might be a kind of technology, not in the sense of artificial intelligence, but as a natural phenomenon that can be developed, refined, and applied in ways that transcend our current understanding of what intelligence can accomplish. Here's where things get really strange, and I'll admit up front that we're moving into territory where conventional science meets speculation and ancient wisdom traditions. But bear with me, because the implications are so profound that they might fundamentally change how we think about the nature of civilization, intelligence, and reality itself. Modern neuroscience has revealed that consciousness is far more mysterious and potentially powerful than we previously understood. The human brain contains roughly 86 billion neurons, each connected to thousands of others through synapses, creating a network of unimaginable complexity. This biological computer consumes only about 20 watts of power, less than a bright light bulb, yet it can perform calculations that would challenge our most advanced supercomputers, generate creative insights that revolutionize entire fields of knowledge, and experience subjective states of awareness that we're only beginning to understand. But what's really fascinating is that consciousness appears to be capable of directly influencing physical reality in ways that challenge our conventional understanding of how the world works. Quantum mechanics, our most successful theory for describing the behavior of matter and energy at the smallest scales, suggests that the act of observation itself fundamentally changes the behavior of subatomic particles. The famous double-slit experiment demonstrates that electrons behave differently depending on whether or not they're being observed, as if consciousness itself plays a role in determining physical reality. This isn't just abstract physics, it has measurable consequences that scientists are still trying to understand. The placebo effect demonstrates that mental states can produce dramatic physiological changes that are indistinguishable from the effects of pharmaceutical interventions. Patients given sugar pills but told they're receiving powerful medications often experience real, measurable improvements in their conditions. Their belief, their conscious expectation, somehow translates into genuine biological changes. Even more intriguingly, some researchers have documented cases where focused intention appears to influence random physical processes. Studies of random number generators have found statistical anomalies that correlate with the presence of human observers who are concentrating on influencing the outcomes. Experiments with plant growth, crystal formation, and even radioactive decay rates have suggested that consciousness might be able to subtly influence physical systems in ways that we don't yet understand. Now, I want to be clear, these effects are typically very small, often barely detectable above the level of statistical noise. Most mainstream scientists remain skeptical about whether consciousness can directly influence physical reality, and the mechanisms by which such influence might operate remain completely unknown. But the fact that these effects are being studied at all by serious researchers at reputable institutions suggests that we may be missing something fundamental about the nature of consciousness and its relationship to the physical world. What if an ancient advanced civilization discovered how to harness these consciousness-based phenomena systematically? What if they developed techniques for directly manipulating matter and energy through focused mental processes, making our kind of mechanical technology obsolete? Think about the implications. Such a civilization might be able to heal diseases through intention rather than medicine. They might transport themselves across vast distances through consciousness projection rather than physical travel. They might communicate directly mind to mind without any technological intermediary. They might even be able to manipulate the fundamental forces of nature, gravity, electromagnetism, the strong and weak nuclear forces through pure mental discipline. This sounds like pure fantasy, like something out of a science fiction novel or ancient mythology. But it's worth remembering that our current understanding of consciousness is embarrassingly primitive. We have no scientific explanation for how subjective experience arises from neural activity. We have no theory for why we are conscious beings rather than unconscious biological machines that simply process information without any inner experience. The hard problem of consciousness explaining why there's a subjective, first-person aspect to mental processes remains one of the greatest unsolved mysteries in all of science. Moreover, we're just beginning to discover that consciousness might be far more fundamental to the nature of reality than we previously thought. Some interpretations of quantum mechanics suggest that consciousness is not an emergent property of complex biological systems, but rather a basic feature of the universe itself, something that exists at all levels of organization, from subatomic particles to galaxies and beyond. If consciousness is indeed fundamental rather than emergent, then the development of advanced consciousness-based technologies might be a natural stage in the evolution of intelligence. Just as we progressed from stone tools to bronze working to iron metallurgy to industrial machinery to computer technology, a more advanced civilization might progress beyond mechanical technology entirely, developing abilities that work directly through the manipulation of consciousness and its relationship to physical reality. Ancient traditions around the world describe exactly these kinds of consciousness-based abilities. Hindu and Buddhist texts describe advanced practitioners who could levitate, teleport, communicate telepathically, and perform what we would consider miraculous healings. Native American traditions speak of shamans, who could travel in spirit to distant locations, communicate with animals and plants, and influence weather patterns through ceremony and focused intention. Ancient Egyptian, Greek, and Celtic traditions describe gods, heroes, and advanced humans who possessed similar abilities. We typically dismiss these accounts as primitive superstition or mythological fantasy. But what if they weren't fantasies? What if they were distorted memories of real human civilizations that had evolved beyond our current level of consciousness development? What if the gods and ascended masters described in ancient traditions were actually humans like us who had discovered how to access and develop the full potential of consciousness? Such a civilization would leave virtually no physical traces that we would recognize as evidence of advanced technology. Their machines would be living beings with enhanced consciousness. Their computers would be trained human minds capable of processing vast amounts of information through direct intuition. Their transportation system would be consciousness projection or direct manipulation of space-time geometry. Their communication network would be telepathic connection between individuals who had learned to access shared levels of consciousness. From our perspective, attempting to study such a civilization through conventional archaeology would be hopeless. We would be looking for physical artifacts and finding none. We would be searching for environmental signatures and discovering only natural systems operating in perfect harmony. We might even encounter living representatives of such a civilization and fail to recognize them as technologically advanced, because their technology would be consciousness-based rather than machine-based. This possibility becomes even more intriguing when we consider the cyclical nature of Earth's climate and the repeated opportunities for intelligence to evolve, develop, and transcend physical limitations over the vast timescales involved in geological and biological evolution. Ancient cultures around the world, despite being separated by vast distances and having no direct contact with each other, developed remarkably similar beliefs about the nature of time and the history of civilization. The Greeks spoke of great ages: golden, silver, bronze, and iron, each representing a decline from a previous era of peace, prosperity, and spiritual development. The Hindus describe vast cosmic cycles called kalpas and yugas, during which the universe goes through repeated phases of creation, development, decline, and destruction, with countless civilizations rising and falling like waves on an infinite ocean. The Maya developed incredibly sophisticated astronomical calendars that tracked not just short-term seasonal cycles, but vast periods spanning millions of years. Their long count calendar, which became famous for allegedly predicting the end of the world in 2012, was actually just one component of a much more complex temporal system that described cycles within cycles extending far into both the past and future. The ancient Egyptians believed that history moved in great cycles governed by astronomical events, particularly the precession of the equinoxes, a 26,000-year cycle caused by the wobble in Earth's rotational axis. They associated different historical periods with different constellations, rising heliacally with the sun, and they believed that human civilization would undergo fundamental transformations as these cosmic cycles completed themselves. Similar cyclical concepts appear in Celtic, Norse, Persian, Chinese, and Native American traditions. The details vary, but the underlying framework is remarkably consistent. Time is not linear but cyclical. Civilizations rise and fall according to natural laws that operate on vast timescales, and what we consider history is just the most recent chapter in a much longer story that has been repeating itself for eons. We typically dismiss these ancient cosmologies as primitive attempts to understand natural phenomena that we now explain through modern science. But what if the ancients were onto something that we've lost sight of in our focus on linear progress and technological advancement? What if the cyclical view of history reflects genuine insights about the long-term patterns governing the development and collapse of complex civilizations? Modern science has indeed discovered that Earth's climate and environment undergo regular cyclical changes that operate on precisely the timescales described in ancient traditions. These cycles are driven by variations in Earth's orbit around the Sun, changes in the planet's axial tilt, and fluctuations in solar output that combine to create complex patterns of warming and cooling over periods ranging from thousands to millions of years. The most well-known of these are the Milankovitch cycles, named after the Serbian mathematician who first described them in detail. These orbital variations create ice ages and interglacial periods that dramatically alter which parts of the planet can support large human populations and complex civilizations. During ice ages, vast areas of currently habitable land are covered by glaciers, sea levels drop by hundreds of feet, and the climate becomes much more variable and unpredictable. During interglacial periods like the one we're currently experiencing, ice sheets retreat, sea levels rise, and stable climatic conditions allow for the development of agriculture and permanent settlements. But here's what's really remarkable. We're currently living in an interglacial period that began about 12,000 years ago, and geological evidence suggests that such periods typically last only 10,000 to 15,000 years before the next ice age begins. In other words, our entire recorded history from the development of agriculture to the present day has taken place during a brief window of unusually stable and favorable climatic conditions that may be ending soon, at least on geological timescales. The previous interglacial period, known as the Eemian, occurred roughly 125,000 years ago and lasted about 15,000 years. During this period, global temperatures were actually slightly warmer than they are today. Sea levels were 15 to 20 feet higher, and the Arctic Ocean was completely ice-free during summer months. If human populations had developed advanced civilizations during the Eemian interglacial, they would have had access to vast areas of habitable land that are now covered by ice sheets, plus extensive coastal areas that are now submerged beneath the ocean. But here's the crucial point: when the Eemian interglacial ended and the last ice age began, it would have created an existential crisis for any advanced civilization that had developed during the warm period. Imagine if global temperatures dropped by 10 degrees Celsius over the course of just a few centuries, if ice sheets miles thick began advancing across northern Europe and North America, if sea levels dropped by 400 feet, exposing vast new land areas while making current coastal cities uninhabitable. Even the most technologically sophisticated civilization would face enormous challenges adapting to such dramatic environmental changes. Food production systems would fail as agricultural areas became too cold for cultivation. Transportation and communication networks would be disrupted by advancing glaciers and changing coastlines. Entire populations would be forced to migrate toward the equator, creating massive social and political upheavals. Some populations might survive by adapting their technology and social organization to ice age conditions, but they would essentially be starting over from scratch. The accumulated infrastructure, knowledge, and cultural achievements that defined their civilization during the interglacial period would be largely irrelevant to the survival challenges posed by glacial conditions. This is precisely what happened to countless species throughout Earth's history. They evolved and thrived during favorable climatic periods, then were driven to extinction when environmental conditions changed faster than they could adapt. But unlike other species, human civilizations have the potential to preserve crucial knowledge and pass it on to successor populations through various forms of cultural transmission. The question is, if advanced civilizations did exist during previous interglacial periods, how would they have attempted to preserve their most important achievements for rediscovery by future civilizations that would eventually develop during subsequent warm periods? This brings us back to those mysterious ancient monuments that have puzzled archaeologists for centuries. Stonehenge, the Great Pyramid of Giza, the massive stone heads of Easter Island, the precisely aligned temples of Angkor Wat, the sophisticated astronomical observatories of Maya cities. These structures have always been explained in terms of religious or ceremonial purposes. But what if they served a much more practical function? What if they were designed as information storage and transmission systems built to preserve crucial knowledge across the vast timescales separating one advanced civilization from the next? If you were a member of an advanced civilization facing imminent collapse due to climatic change, cosmic catastrophe, or some other existential threat, and you wanted to preserve your most important knowledge for rediscovery by future civilizations that might emerge thousands or tens of thousands of years later, how would you go about it? You couldn't rely on any conventional information storage technology. Digital systems degrade within decades. Magnetic storage loses its data even faster. Paper, parchment, and other organic materials decompose within centuries at most. Even our most durable metals, steel, aluminum, titanium, will corrode completely over timescales of thousands to tens of thousands of years, when exposed to natural weathering processes. You would need something essentially permanent, something that could survive ice ages, volcanic eruptions, earthquakes, floods, and the rise and fall of multiple subsequent civilizations. You would need materials that remain stable over geological timescales, and you would need encoding methods that could be deciphered by people who might have completely different languages, technologies, and cultural frameworks from your own. In other words, you would need stone. Stone monuments are among the few human artifacts that can survive for millions of years with minimal change. The Great Pyramid of Giza has stood for over 500 years and shows every sign of being able to last for hundreds of thousands more. The massive trilithons at Stonehenge have weathered more than 4,000 years of British climate and could potentially survive for geological ages. Even relatively soft limestone and sandstone structures can remain intact for tens of thousands of years if they're built with sufficient engineering skill and placed in favorable locations. But what kind of information could such monuments encode, and how could it be made accessible to future civilizations that might have radically different scientific and mathematical knowledge? The answer, I believe, lies in astronomy and mathematics, the universal languages that any scientifically advanced civilization must necessarily develop in order to understand the natural world. Astronomical phenomena follow precise mathematical laws that remain constant across vast spans of time. The movements of celestial bodies, the cycles of seasons, the precession of the equinoxes, these provide a stable reference frame that could serve as the basis for encoding more complex information. Consider the extraordinary astronomical alignments found at megalithic sites around the world. Stonehenge tracks the movements of the sun and moon with remarkable precision, allowing accurate prediction of eclipses, solstices, and other celestial events. The three main pyramids at Giza align perfectly with the stars of Orion's belt as they appeared in the night sky 500 years ago, while the shafts inside the Great Pyramid point towards specific stars that held special significance in ancient Egyptian astronomy. The temple complex at Angkor Wat in Cambodia incorporates sophisticated astronomical alignments that correspond to important dates in the Hindu calendar and track the precession of the equinoxes over vast periods of time. The Maya developed astronomical observations of extraordinary accuracy, tracking the movements of Venus, Mars, and other planets with precision that wasn't matched by European astronomers until the development of telescopes. These weren't just religious symbols or primitive calendars. They were precision instruments designed to encode astronomical knowledge in permanent, easily recognizable form. But why were ancient peoples so obsessed with astronomy, and why did they invest enormous resources in creating monuments that tracked celestial phenomena with such incredible accuracy? Here's a possibility that might sound like science fiction, but is actually supported by growing scientific evidence. Astronomical events can serve as timestamps for geological and climatic changes that occur on predictable cycles. If you wanted to warn future civilizations about recurring catastrophes, ice ages, magnetic pole reversals, asteroid impacts, supervolcanic eruptions, or other cyclical disasters, you might encode that information in the form of astronomical alignments that would only become meaningful to people who had developed sophisticated mathematical and observational techniques. Think about the Antikythera mechanism, that remarkable bronze device discovered in a Roman shipwreck in 1901. For decades, archaeologists couldn't figure out what it was. It seemed far too sophisticated to be an ancient artifact. Then, in the 1970s and 1980s, researchers using X-ray imaging and computer modeling realized that it was actually an incredibly complex astronomical computer, capable of predicting the positions of the sun, moon, and planets hundreds of years into the future, as well as calculating the dates of Olympic Games and other important cultural events. The Antikythera mechanism demonstrates that ancient civilizations possessed far more sophisticated technological capabilities than we previously believed. It also suggests that they were deeply concerned with tracking long-term astronomical cycles for reasons that we still don't fully understand. Why would anyone need to predict planetary positions centuries into the future unless they knew something about how celestial mechanics relates to earthly events on very long timescales? Modern research in the field of astrobiology and cosmic catastrophe theory has revealed that astronomical events do indeed have profound effects on Earth's climate and biological evolution. Variations in Earth's orbit and axial tilt drive ice age cycles, Changes in solar output affect global temperatures over periods of centuries to millennia. Nearby supernovas can trigger mass extinctions by bombarding Earth with high-energy radiation. Asteroid and comet impacts have repeatedly caused global catastrophes that eliminated large percentages of existing species. If ancient advanced civilizations had developed the scientific knowledge necessary to understand these connections, they might have attempted to preserve warnings about future catastrophes in the form of astronomical monuments that would serve as both observatories and information storage systems. The monuments would be designed to demonstrate their builders' sophisticated understanding of celestial mechanics, while simultaneously encoding specific information about the timing and nature of recurring disasters. But astronomical alignments aren't the only way that crucial information could be preserved in stone monuments. Mathematical relationships, geometric principles, and even complex technological specifications could be encoded in the proportions, dimensions, and architectural features of megalithic structures. The Great Pyramid, for example, incorporates the mathematical constant pi, the ratio of a circle's circumference to its diameter, in its basic proportions, despite the fact that pi wasn't supposedly discovered by Greek mathematicians until thousands of years later. The pyramid's base perimeter divided by its height equals 2 high with remarkable accuracy. Its internal chambers and passages are positioned according to precise geometric relationships that encode sophisticated mathematical knowledge. Similarly, Stonehenge incorporates complex geometric relationships that demonstrate advanced understanding of trigonometry, coordinate geometry, and astronomical mathematics. The positions of the stones create sight lines that point towards significant astronomical events, while the overall layout encodes mathematical relationships that wouldn't be formally described by mathematicians until the development of advanced algebra and calculus. But here's the truly mind-bending possibility: what if these ancient monuments aren't just preserving knowledge about astronomy and mathematics? What if they're actually encoding much more complex information, technological specifications, historical records, maps of advanced civilizations, or even warnings about specific future events that can be predicted through sophisticated understanding of cyclical patterns in natural and social systems? Modern researchers using ground-penetrating radar, satellite imagery, and computer modeling are discovering that many ancient sites are far more complex than previously believed. Hidden chambers, underground tunnel networks, and precisely aligned secondary structures suggest that places like Giza, Stonehenge, and Teotihuacan were components of much larger information systems that we're only beginning to understand. The ancient Egyptians believed that the god Thoth had preserved the wisdom of previous civilizations in secret chambers beneath the Sphinx and in hidden rooms within the pyramids. The Greeks wrote about Atlantean knowledge being preserved in underground temples and libraries that could only be accessed by those who possessed the proper keys and understanding. Hindu traditions describe vast underground cities where advanced knowledge was stored in crystal libraries that could preserve information for millions of years. What if these weren't myths but actual descriptions of information preservation systems created by previous advanced civilizations? What if we're surrounded by messages from the deep past, encoded in monuments that have been staring us in the face for thousands of years, waiting for us to develop the scientific and mathematical sophistication necessary to decode them? Let's step back for a moment and try to grasp the truly mind-bending scales of time we're dealing with when we talk about the possibility of ancient advanced civilizations. This is where our normal human intuition completely fails us, because we evolved to think in terms of human lifespans, seasons, and at most a few generations. But the story we're exploring operates on timescales that dwarf human experience so completely that our brains literally cannot process them without considerable effort. Complex life organisms with distinct cells, tissues, and organs has existed on Earth for approximately 600 million years. During that vast span of time, there have been at least 5 major mass extinction events that eliminated between 70% and 96% of all species on the planet. The most recent of these, the Cretaceous-Paleogene extinction that ended the reign of the dinosaurs, occurred 66 million years ago. 66 million years. Let me try to give you some perspective on what that means. If you could somehow compress the entire span of time from the extinction of the dinosaurs to the present moment into a single year, then the entire recorded history of human civilization, from the first written languages to the space age, would occupy approximately the last hour of December 31st. The Renaissance would have begun about 20 minutes ago. The Industrial Revolution would have started in the last 3 minutes. The computer age would have begun in the last 30 seconds. And that's just the most recent extinction event. If we go back to the beginning of complex life 600 million years ago, human civilization becomes so brief as to be essentially instantaneous. We appeared an eye blink ago, and we could disappear tomorrow, and the planet would barely notice our absence. This isn't meant to be depressing, it's meant to be liberating. When you truly grasp the age of the Earth and the brevity of human existence, it frees you from what the paleontologist Stephen Jay Gould called temporal chauvinism, the assumption that our particular moment in time is somehow special or represents the culmination of evolutionary development. We are not the end point of evolution. We are not the first intelligence to arise on Earth, and we will certainly not be the last. We are just one experiment in consciousness among countless others, most of which have vanished completely from the fossil record, leaving behind only the faintest traces of their existence. But that doesn't make us insignificant. It makes us part of something much larger and more mysterious than we ever imagined. Consider this: during the 600 million years that complex life has existed on Earth, there have been countless opportunities for intelligence to evolve, develop technology, create civilizations, and then disappear back into the geological record. The dinosaurs alone ruled the planet for 180 million years, 3 times longer than mammals have existed, and nearly 1,000 times longer than human civilization has persisted. During that vast span of time, trillions of individual dinosaurs lived and died. Some species developed remarkably sophisticated behaviors, complex social structures, elaborate communication systems, advanced problem-solving abilities. The smaller theropod dinosaurs, in particular, showed signs of intelligence that approached or possibly exceeded that of modern birds, which are, after all, their direct descendants. Is it possible that some dinosaur species developed proto-civilizations? Could there have been dinosaur societies with agriculture, tool use, and social organization advanced enough to leave traces in the geological record? Almost certainly not. Their brain structures were too different from mammalian brains. Their manipulative abilities were limited by their body plans, and there's no evidence in the fossil record of the kind of technological development that would be necessary for true civilization. But the point is not whether dinosaurs specifically developed advanced civilizations. The point is that 180 million years is an almost incomprehensible amount of time. If intelligence is a natural consequence of evolutionary development, and there's good reason to think that it is, then there were countless opportunities for some form of advanced consciousness to emerge during the age of dinosaurs, develop to levels we can't imagine, and then vanish completely when the asteroid impact or volcanic catastrophe that ended the Mesozoic era destroyed the environmental conditions that supported their existence. The same logic applies to the periods before and after the dinosaurs. Complex life has been experimenting with different approaches to intelligence for 600 million years. Cephalopods like octopi and squid developed remarkably sophisticated cognitive abilities along completely different evolutionary pathways from vertebrate intelligence. Some of them demonstrate problem-solving skills, tool use, and even rudimentary forms of communication that suggest they possess forms of consciousness very different from, but possibly as complex as, our own. What if cephalopod intelligence had 100 million years to develop, instead of the relatively brief period during which it actually evolved? What if some branch of mollusk evolution had produced creatures with both advanced intelligence and the manipulative abilities necessary for tool use and construction? They would be so alien to us that we might not even recognize their artifacts as products of intelligence, especially if those artifacts were made from organic materials that would decompose completely over geological timescales. This is what I mean by the deep time perspective. When you operate on the timescales relevant to geological and biological evolution, the emergence of intelligence stops being a rare accident and starts looking like an inevitable consequence of increasing complexity in natural systems. Consciousness appears to be a natural property that emerges whenever information processing systems reach sufficient levels of sophistication, whether those systems are biological brains, artificial computers, or perhaps forms of organization that we haven't discovered yet. If that's true, then Earth's history is not the story of lifeless matter gradually becoming more complex until it finally produces intelligence in the form of human beings. Instead, it's the story of intelligence continuously rediscovering itself in new forms, reaching toward greater understanding and capability, and then transforming into something even more sophisticated as conditions change and new opportunities arise. We humans represent just the most recent iteration of this ongoing process. We've achieved a level of technological development that allows us to manipulate our environment, store and transmit information across generations, and begin to understand the deep patterns that govern natural and social systems. But we're certainly not the final stage of this process, any more than the first microscopic cells were the final stage of biological evolution. The question is, what comes next? And perhaps more importantly, what came before us during the countless previous cycles of intelligence emergence and transformation that must have occurred during Earth's long history? If ancient advanced civilizations did exist and wanted to preserve their most crucial knowledge for rediscovery by future intelligences that might emerge thousands or millions of years later, they would have faced the same fundamental challenge that we're beginning to confront today. How do you store information reliably across geological timescales? This isn't just a theoretical problem. We're already dealing with it in our own civilization as we try to figure out how to mark nuclear waste storage sites so that future human societies will be able to identify and avoid dangerous areas even if our current languages, symbols, and cultural frameworks have been completely forgotten. The US Department of Energy has spent millions of dollars studying this problem, consulting with linguists, anthropologists, semioticians, and artists to develop marking systems that could remain comprehensible for at least 10,000 years. But 10,000 years is nothing compared to the timescales we're talking about when we consider the possibility of multiple cycles of advanced civilization over geological time. If previous advanced civilizations wanted to communicate with their successors across spans of hundreds of thousands or millions of years, they would need much more robust preservation methods. We've already established that conventional information storage technologies won't work over such timescales, but there are some fascinating alternatives that could theoretically preserve complex information across geological ages. One possibility is genetic encoding. DNA is the most durable information storage system we know of in nature. Under favorable conditions, genetic material can remain intact and readable for millions of years. Scientists have successfully extracted and sequenced DNA from organisms that died hundreds of thousands of years ago, and theoretical studies suggest that genetic information could potentially survive for millions of years if it were properly protected from radiation, heat, and chemical degradation. Modern biotechnology companies are already experimenting with using synthetic DNA to store digital information. The data density is extraordinary. A single gram of DNA can theoretically store 215 petabytes of data, which is roughly equivalent to the entire contents of the internet. The information is encoded in the sequence of nucleotide bases that make up the DNA molecule, and it can be read using the same techniques that biologists use to sequence naturally occurring genes. An advanced ancient civilization might have developed sophisticated techniques for encoding their most crucial knowledge directly into the genomes of various species, particularly long-lived organisms like trees, deep-sea creatures, or extremophiles that can survive in harsh environments for extended periods. The information would be preserved as long as those species continued to exist and reproduce, and it could theoretically be recovered by any future civilization that developed the biotechnology necessary for genetic sequencing and analysis. From our perspective, such information would be completely invisible unless we knew exactly what to look for and had the technological capabilities necessary to detect and decode it. The encoded knowledge might exist in what we currently consider junk DNA, genetic sequences that don't appear to serve any obvious biological function, or it might be hidden in the genomes of organisms that we haven't yet studied in detail, waiting for future advances in biotechnology to make it accessible. Another possibility is crystalline encoding. Certain crystal structures can remain stable for billions of years under normal environmental conditions. Quartz crystals, for example, are extremely resistant to weathering, chemical attack, and thermal cycling. They can theoretically preserve information encoded in their atomic lattice structure across geological timescales while remaining completely invisible to conventional archaeological techniques. Recent advances in materials science have demonstrated that it's possible to encode digital information in synthetic crystals using laser writing techniques that create microscopic structural modifications in the crystal lattice. These modifications can store data at densities comparable to DNA encoding, and the information can be retrieved using specialized optical reading systems. The storage medium is essentially permanent. A quartz crystal containing encoded information could survive for millions of years without significant degradation. An ancient advanced civilization with sophisticated materials science capabilities might have developed much more elegant techniques for crystalline information storage. They could have created information crystals that look like perfectly natural mineral formations, but actually contain vast libraries of encoded knowledge. Such crystals could be buried in stable geological formations, placed in deep caves, or even incorporated into the structure of monuments and buildings where they would be protected from environmental damage. But perhaps the most intriguing possibility is what we might call cultural encoding, embedding crucial information in myths, legends, oral traditions, and religious practices that could be passed down through countless generations of successors, civilizations, gradually evolving and adapting while preserving their essential core messages. This is actually one of the most robust information preservation systems ever developed by human societies. Stories can survive the complete collapse of civilizations, the loss of written languages, and massive cultural disruptions. They adapt to new contexts and incorporate new details, but they often preserve remarkably accurate information about historical events across spans of thousands of years. Consider the global distribution of flood myths, which appear in cultures around the world with remarkable consistency despite the fact that many of these cultures had no direct contact with each other. The biblical account of Noah's flood, the Mesopotamian epic of Gilgamesh, Hindu stories of Manu surviving a world-destroying deluge, Greek legends of Deucalion and Pera, Native American flood traditions, these narratives share so many specific details that they almost certainly preserve distorted memories of actual historical events. Most geologists now believe that these flood myths reflect cultural memories of the dramatic sea level rise that occurred at the end of the last ice age, when the melting of glacial ice sheets caused ocean levels to rise by over 400 feet in a relatively short period of geological time. Coastal settlements around the world would have been gradually flooded, forcing large populations to migrate to higher ground and creating the kind of traumatic collective memory that gets preserved in oral tradition for thousands of years. But what if other seemingly mythological narratives preserve equally important information about much more ancient events? What if stories about lost golden ages, divine teachers who brought civilization to primitive peoples, or cosmic cycles of creation and destruction are actually distorted memories of real encounters between successive waves of advanced civilizations? Ancient traditions around the world describe remarkably similar themes: advanced beings who possessed God-like powers and knowledge, golden ages of peace and prosperity that were destroyed by catastrophes, hidden wisdom that was preserved in secret locations for future rediscovery, and cyclical patterns of rise and fall that govern the development of civilizations over vast periods of time. We typically dismiss these stories as primitive attempts to understand natural phenomena or as religious allegories designed to teach moral lessons. But what if they represent something much more significant? What if they are the degraded remains of sophisticated information preservation systems created by previous advanced civilizations to transmit crucial knowledge about cyclical catastrophes, advanced technologies, or the fundamental nature of consciousness and reality? If so, then we might be surrounded by messages from the deep past, encoded in the mythologies and spiritual traditions that we've inherited from our ancestors, waiting for us to develop the interpretive frameworks necessary to decode their original meanings and recover the advanced knowledge they were designed to preserve. This brings us to one of the most profound and disturbing questions in all of science: where is everybody? The Fermi paradox, named after the physicist Enrico Fermi, who first articulated it clearly, points out that given the vast age and size of the universe, the apparently high probability of life emerging on suitable planets, and the exponential growth potential of any successful civilization, we should be seeing evidence of extraterrestrial intelligence everywhere we look. The numbers are staggering. Our galaxy alone contains between 100 billion and 400 billion stars. Recent discoveries by the Kepler Space Telescope and other planet hunting missions suggest that most stars have planetary systems and that rocky planets in the habitable zone, where liquid water can exist, are remarkably common. Even conservative estimates suggest that there should be millions or billions of planets in our galaxy alone, where conditions are suitable for the development of life. If life is a natural consequence of suitable chemical and physical conditions, and the rapid emergence of life on early Earth suggests that it is, then biological evolution should be occurring on countless planets throughout the galaxy. And if intelligence is a natural consequence of evolutionary development, which seems reasonable given that it has evolved multiple times independently on Earth, then there should be millions of technological civilizations scattered across the Milky Way. Some of these civilizations should be much older than ours. If intelligence emerged on another planet just 1 million years before it appeared on Earth, which is a tiny interval in cosmic terms, then that civilization would have had 1 million years to develop technologies and expand across interstellar space, even with relatively slow spacecraft traveling at just a few % of the speed of light. 1 million-year head start would be more than enough time to colonize the entire galaxy. Yet, despite decades of increasingly sophisticated searches, we've found absolutely no evidence of extraterrestrial intelligence. No radio signals, no optical beacons, no massive engineering projects, no signs of industrial activity on other planets. The universe appears to be completely sterile, devoid of any intelligence other than our own. This absence is so puzzling that scientists have proposed dozens of potential explanations, ranging from the pessimistic to the exotic. Maybe technological civilizations inevitably destroy themselves through warfare, environmental collapse, or resource depletion before they can expand beyond their home planets. Maybe interstellar travel is much more difficult than we think, or maybe advanced civilizations choose not to expand into space for cultural or philosophical reasons. Maybe we're looking for the wrong kinds of signals, or maybe extraterrestrial intelligence is so advanced that we can't recognize its artifacts as artificial. But what if the real answer is much stranger than any of these conventional explanations? What if the Fermi paradox is based on a fundamental misunderstanding about the natural trajectory of intelligent civilizations? We assume that advanced civilizations would want to expand physically into space, building starships and colonies and massive industrial complexes that would be detectable from interstellar distances. This assumption is based on our own current phase of technological development, where advancement is associated with larger, more powerful, more resource-intensive technologies. But what if this represents just a brief transitional phase in the evolution of intelligence? What if the natural trajectory of advanced civilizations leads not toward physical expansion, but towards something completely different: dimensional transcendence, consciousness evolution, or integration with fundamental aspects of reality that we can't even conceive of yet? Think about the direction our own civilization is already heading. We're spending increasing amounts of time in virtual environments, social media platforms, video games, augmented reality systems that overlay digital information on physical space. Our most meaningful activities, research, communication, creativity, entertainment, social interaction increasingly happen in informational rather than physical space. This trend is accelerating rapidly. Virtual and augmented reality technologies are becoming more sophisticated and immersive. Artificial intelligence systems are developing capabilities that complement and enhance human cognition. Brain-computer interfaces are beginning to allow direct neural connection to digital systems. Genetic engineering and nanotechnology are blurring the boundaries between biological and artificial systems. We're already beginning to live primarily in realities of our own creation, and this process shows no signs of slowing down. Within a few decades, the distinction between real and virtual experience may become completely meaningless. People may spend most of their time in simulated environments that are more interesting, more beautiful, and more emotionally satisfying than physical reality. Now imagine this process continuing for thousands or millions of years, and sufficiently advanced civilization might eventually transition completely into virtual existence, creating infinite worlds of pure consciousness where the limitations of physical reality, scarcity, distance, entropy, death simply don't apply. They wouldn't need starships because they could instantly travel to any location in their simulated universes. They wouldn't need to colonize planets because they could create entire worlds within their computational systems. They wouldn't need to gather resources because information can be copied and shared without loss. They wouldn't even need physical bodies because their consciousness could exist as pure information patterns in quantum computational substrates. From our perspective, such civilizations would appear to vanish completely. They would leave no physical traces, send no radio signals, build no megastructures that we could detect with our current technologies. They would exist in dimensions of reality that are completely invisible to us, not because they're hiding, but because they've evolved beyond the need for physical existence entirely. This could explain both the Fermi paradox and the absence of obvious evidence for ancient terrestrial civilizations. Advanced intelligences don't expand into physical space because they don't need to. Instead, they transcend physical limitations by developing technologies of consciousness that allow them to create infinite realities within computational systems that exist in higher, dimensional spaces we can't even perceive. They didn't die out or destroy themselves. They graduated to levels of existence that are as far beyond our current understanding as our civilization is beyond that of bacteria. And if this is the natural destiny of intelligence to evolve beyond physical reality entirely, then it provides a compelling explanation for why the universe appears to be empty of technological civilizations. They're all still here, existing in parallel dimensional spaces that interpenetrate our physical reality, but remain completely invisible to our current methods of observation and detection. This possibility becomes even more intriguing when we consider that some interpretations of quantum mechanics suggest that consciousness might play a fundamental role in the structure of reality itself. If consciousness is not just an emergent property of complex biological systems, but actually a basic feature of the universe, then the development of advanced consciousness-based technologies might allow civilizations to directly manipulate the fundamental laws of physics in ways that transcend our current understanding of what's possible. We're rapidly approaching what we might call an archaeological singularity, a point where our ability to detect and understand ancient civilizations will be fundamentally transformed by new technologies and methodologies that are currently in development. This transformation will be so dramatic that within the next few decades, we may discover evidence of previous advanced civilizations that has been hiding in plain sight, waiting for us to develop the analytical capabilities necessary to recognize it. Artificial intelligence is already beginning to revolutionize archaeology in ways that most people don't fully appreciate. Machine learning algorithms can analyze satellite imagery to identify potential archaeological sites with accuracy that exceeds human experts. AI systems can process vast databases of artifacts to identify previously unnoticed patterns and connections that reveal new insights about ancient cultures. Neural networks are learning to translate ancient languages and decipher scripts that have puzzled scholars for centuries. But these are just the beginning applications of AI in archaeology. As our computational capabilities continue to expand exponentially, we'll be able to apply much more sophisticated analytical techniques to archaeological problems. We'll be able to analyze patterns in the geological record that are too subtle for human perception, detect anomalies in natural systems that might indicate artificial modifications, and correlate information across multiple data sources in ways that reveal hidden connections between apparently unrelated phenomena. Quantum sensors are being developed that can map underground features with unprecedented precision, potentially revealing hidden chambers in pyramids, lost cities beneath deserts, or artificial modifications to natural landscapes that occurred millions of years ago. These devices use quantum entanglement and other exotic physical phenomena to detect tiny variations in gravitational fields, magnetic fields, and other properties that indicate the presence of buried structures or materials. Ground-penetrating radar, magnetometry, and LIDAR scanning are becoming so sophisticated that we can essentially see through the Earth itself, creating detailed three-dimensional maps of subsurface features without disturbing the soil. Hyperspectral imaging from aircraft and satellites can detect chemical signatures that indicate human activity at sites where no visible artifacts remain on the surface. Most importantly, we're developing entirely new theoretical frameworks for thinking about intelligence, consciousness, and the traces that advanced civilizations might leave behind. We're learning to look for evidence in places we never thought to examine, in genetic codes, in mathematical constants, embedded in natural phenomena, in the fundamental structure of space-time itself. If ancient advanced civilizations did exist and wanted to communicate with their successors, they might have encoded messages in the cosmic microwave background radiation that fills all of space, in the distribution of prime numbers, in the quantum field fluctuations that underlie physical reality, or in other aspects of the universe that would only be accessible to civilizations that had achieved sufficient scientific sophistication to detect and analyze such phenomena. These would be messages that could survive for billions of years without degradation, that would be accessible from anywhere in the universe, and that would serve as a kind of cosmic intelligence test. Only civilizations advanced enough to understand the underlying physics would be able to detect and decode the information. We're getting very close to passing that test. Within the next few decades, we may have the theoretical understanding and technological capabilities necessary to detect artificial signatures in data streams that we currently interpret as natural phenomena. We may discover that the universe itself has been modified by intelligence operating on scales we can barely comprehend, that what we think of as natural constants and physical laws actually bear the subtle fingerprints of previous cosmic civilizations. But perhaps even more exciting is the possibility that we'll find evidence of ancient civilizations much closer to home. Advanced AI systems may discover patterns in the archaeological record that reveal the existence of previous technological civilizations on Earth. Quantum sensors may locate artificial structures buried beneath miles of sediment or hidden in the deep ocean trenches. Genetic analysis may reveal encoded information in the DNA of various species that preserves libraries of ancient knowledge. We may find that the monuments and megalithic sites that have puzzled us for centuries actually contain sophisticated information encoding systems that we're only now developing the mathematical and technological capabilities to decode. The Great Pyramid, Stonehenge, Easter Island, Angkor Wat, these sites may turn out to be components of a vast information network created by previous civilizations to preserve crucial knowledge for rediscovery by their successors. As we stand on the threshold of potentially detecting ancient advanced civilizations, we must confront an uncomfortable truth about our own civilization's future. We are simultaneously searching for evidence of previous intelligences while creating the conditions for our own eventual invisibility to future archaeologists. Our most significant achievements are increasingly ephemeral and intangible. Our greatest art exists as digital files that could disappear if our storage systems fail or become obsolete. Our most important knowledge is preserved in formats that are already becoming unreadable as technologies evolve. Our scientific discoveries are documented in electronic databases that require continuous maintenance and periodic migration to new systems to remain accessible. Our cities are built with materials designed to last centuries, not millennia. Steel and concrete structures will crumble within a few hundred years without constant maintenance. Our transportation networks are optimized for efficiency rather than permanence. Our power generation and distribution systems are so complex and interdependent that they would fail completely within months if our technological civilization collapsed. Even more troubling, we're entering an era of potentially exponential technological development that could transform human society beyond recognition within just decades. Artificial intelligence systems are developing capabilities that may soon exceed human performance in most cognitive tasks. Genetic engineering techniques are beginning to allow direct modification of human biology. Nanotechnology promises to give us precise control over matter at the molecular level. Quantum computing may provide computational capabilities that dwarf anything we can currently imagine. These technologies could allow us to transcend biological limitations, merge our consciousness with artificial intelligence systems, upload our minds to quantum computers, or disperse our awareness into digital realities that bear no resemblance to current human existence. We could become something so different from our current selves that future archaeologists would have no way to recognize us, as the same species that created 21st century human civilization. From the perspective of scientists living 1 million years from now, our current technological phase might appear as nothing more than a brief anomaly in the geological record, a thin layer of unusual isotopes, exotic materials, and electromagnetic signatures sandwiched between more stable periods of purely biological evolution. But this isn't necessarily tragic. It might be natural. It might even be beautiful. What if the purpose of intelligence isn't to create permanent monuments to itself, but to serve as a bridge between different phases of cosmic evolution? What if consciousness is the universe's way of understanding itself, and each civilization, no matter how brief, contributes something essential to that ongoing process of self-discovery? The Atlantis paradox teaches us that impermanence isn't a design flaw in the cosmic system, it's a feature. Civilizations rise and fall like waves on an infinite ocean, each one carrying forward elements from those that came before while adding something new to the ever-evolving complexity of consciousness and intelligence. We are part of that eternal process. Our specific technological civilization may disappear within a few centuries or millennia, but the consciousness and intelligence that created us will continue in new forms that we cannot yet imagine. The knowledge we've gained, the problems we've solved, the beauty we've created, the love we've experienced, all of this becomes part of the permanent record of what intelligence can accomplish when it emerges in the universe. The ocean itself is eternal, even though individual waves are temporary. We are temporary waves in an eternal ocean of consciousness that has been exploring itself through countless forms for billions of years and will continue to do so for billions more. And so we return to where we began, standing on that Mediterranean shore at sunset, watching golden waves crash against ancient limestone cliffs. But now we see those waves differently. Each one carries within itself the memory of countless others that came before, waves that crashed on shores that no longer exist, witnessed by eyes that closed long ago, remembered in minds that have transcended physical form entirely. The legend of Atlantis isn't really about a specific lost civilization that may or may not have existed in some particular location at some specific time in the past. It's about something much more profound and universal, the eternal cycle of emergence and transcendence, creation and transformation, that defines the relationship between consciousness and the cosmos. It's about the recognition that everything we build, everything we achieve, everything we think is permanent and lasting, will eventually be transformed into something else. Our cities will crumble, our monuments will erode, our technologies will become obsolete, our civilizations will be forgotten. But the consciousness that created all of these things, the awareness, the intelligence, the capacity for wonder and understanding that makes civilization possible in the first place, that consciousness is eternal and indestructible. It takes new forms in each generation, each species, each evolutionary experiment in the ongoing adventure of intelligence exploring itself through material existence. What we call history is just the most recent chapter in a story that has been unfolding for billions of years and will continue for billions more. Maybe Atlantis was real in the way that Plato described it, a specific advanced civilization that flourished and vanished during some previous cycle of climatic and cultural development. Maybe it was a composite memory of multiple ancient civilizations, combined and mythologized through countless retellings until the historical details became impossible to separate from legendary embellishments. Maybe Atlantis exists somewhere beneath the Mediterranean waves, waiting for us to develop the technology necessary to find and explore its ruins. Maybe it exists in parallel dimensions of reality that we haven't learned to perceive yet. Maybe it exists in the quantum computational substrates where advanced civilizations go when they transcend the need for physical existence. But in the end, it doesn't matter whether we ever find physical evidence of Atlantis or any other lost civilization. The real treasure isn't in the ruins themselves, but in what the search teaches us about the nature of time, consciousness, and our place in the cosmic story of intelligence evolving toward ever greater understanding and capability. We are temporary arrangements of matter and energy that have somehow learned to contemplate our own existence and wonder about our origins and destiny. We are the universe awakening to itself, asking questions about its own nature and history. And when our particular moment of awareness passes, as it inevitably must, Other temporary arrangements of matter and energy will continue the eternal conversation between mind and cosmos. The waves keep crashing, the shore keeps changing, the ocean itself remains eternal, expressing itself through countless individual waves while transcending any particular manifestation. And consciousness keeps exploring new ways to understand itself through forms we cannot yet imagine, forms that may be as far beyond our current understanding as we are beyond the first microscopic cells that learned to process information and respond to their environment billions of years ago. Perhaps that's the most profound lesson of the Atlantis paradox. We are not seeking lost civilizations in the past or waiting for contact with extraterrestrial intelligence in the future. We are creating the next chapter of the cosmic story right now, in this moment, through every act of awareness and understanding and compassion that we bring to our brief existence as conscious beings in an apparently infinite universe. We are Atlantis. We have always been Atlantis, and we always will be, regardless of what form we take or how completely our current physical traces disappear into the deep time that flows beneath all things like an underground river, carrying the eternal story of consciousness forward into whatever comes next. The mystery continues, the search never ends, and somewhere in the vast expanse of space and time, other manifestations of consciousness are asking the same questions, seeking the same understanding, wondering if they are alone in their brief dance between existence and eternity. They are not alone, neither are we. We are all waves in the same infinite ocean, temporary expressions of something eternal and magnificent beyond our current ability to comprehend fully. And that recognition, that deep knowing of our fundamental connection to all consciousness everywhere and everywhen, might be the most important discovery we can make, more valuable than any archaeological artifact or technological achievement. So the next time you stand beside any body of water, ocean, lake, river, or even a simple stream, remember that you are looking at a mirror that reflects not just your individual face, but the face of every conscious being that has ever existed or ever will exist. We are all part of the same eternal story, writing ourselves into existence one moment at a time, leaving traces that future versions of ourselves will someday discover and wonder about, just as we wonder about Atlantis today. The circle closes, the spiral rises, and the eternal return continues its ancient rhythm, carrying consciousness forward into whatever magnificent forms await in the endless adventure of intelligence exploring itself through the medium of space and time. And that, perhaps, is the deepest truth hidden within the legend of Atlantis. Not that advanced civilizations can disappear without leaving physical traces, but that consciousness itself is the most important trace they leave behind. The eternal gift that keeps giving across all the vast spans of time, carrying forward the endless quest to understand what it means to exist as awareness in this strange and wonderful universe we temporarily call home. The story continues, it always has, it always will, and we are all part of it, contributing our own unique verse to the infinite poem of consciousness, discovering itself through countless eyes, countless minds, countless moments of wonder, and understanding that together weave the ongoing tapestry of intelligence, evolving toward whatever